Hey guys, welcome. We're starting chapter 7 and we're talking about similarity, and in order to understand similarity we need to talk about ratios and proportions. Okay, similarity is talking about two shapes that look the same. Think of a car and its model car. They have the same look, but they are actually in the same proportion or ratio to each other, even though they're not the same size. So let's go ahead and get started. We're going to go over a couple of these definitions. First thing we want to talk about is a ratio. So let's write down our definitions. So our first definition here, we want to write this down right here. A ratio is a comparison of two quantities by division. You can write the ratio of two numbers a, b does not equal 0, in three ways: a over b, a colon b, and a to b. Usually express a and b in the same unit, very important, the same unit, and write the ratio in the simplest form. Okay, so that, make sure you get that down. So we're going to be talking a lot about ratios in this chapter. Let's go ahead and move to another one of our key terms. So one second. Okay, so just kind of fast forward over here. Another key concept we want down are all this information. An equation that states that two ratios are equal is called a proportion. And we're going to get an example of proportions a lot here. The first and last numbers in the proportion are called extremes. I think of them as extremes because they're on the furthest points. They're really far on the outside, and the inside ones are the means. So we have here 2 to 3 is equal to 4 to 6. 2 and 6 are the mean extremes, and 3 and 4 are the means. The middle two numbers we call the means, and this is how we cross multiply, which you probably are very familiar with, cross products. So make sure you write down all these definitions, and please pause the video and take note of this box right now. So copy that down. Alright, we're going to move on to the next thing. So hopefully you've copied this down already. And let's go ahead. I'm going to pause it so I can skip it fast. Okay, so I actually just kind of took that cross products property box. Hopefully you already wrote it down. I just made it a little bit bigger here so you can see it. But in proportion, the product of the extremes equals the product of the means. We do this a lot, where B and C multiply, A and D multiply. We're going to talk more about what this is called with the means and extremes as we further into this journey, but this is how we would solve a proportion. So we're going to jump into our first problem. So here we go. Okay, so take a look. We are looking at a bonsai bald cypress tree. Shown here is a small version of a full-size tree. So this is a miniature version. In Longwood, Florida, a bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? Well, if we come in here and look, we have the height of the bonsai right here. Well, that's given to us right here as 15 inches. And then we could say the height of the Senator was given to us in the problem. So if we want to actually do this, we could do this pretty easily. Now it said bonsai to Senator, so we're going to put bonsai on top. So we can just write 15 inches over, and that's 118 feet. Now here's the problem. When we talked about ratios in the beginning, the definition said we want it to be in the same, oh gosh, I'm blanking on the word. Help me out, class. Units, thank you. Same units. Okay, there's no actual class here. So inches and feet are not in the same units, so we don't want to actually leave it like this, so we need to make a conversion. So the simplest thing to do is for us to convert feet into inches. We could also convert inches into feet, but then we'll probably end up with a fraction because I think 15 won't fit in evenly. So we got to do a little conversion. So we got to turn 118 feet into inches. And hopefully most of you realize that 1 foot is equivalent to 12 inches. So this is a fair assessment to say 1 foot and 12 inches is the same. This is actually a 1-to-1 ratio. So if I multiply 118 feet over 1 times this, the feet are going to cancel out, and we multiply 118 times 12. Well, you got to make sure you have a calculator to do this. So luckily, where's my calculator? Oh man. You reach out, grab your calculator, and we can go ahead and just do 118 times 12 inches. And if we do that, we do 118 times 12, we get 1,416 inches. So we can rewrite this sentence as 15 over 1,416 inches. And there is our ratio. Okay? Right there. Now we could look for reducing it, and if you have the fancy smancy calculator like I do, it'll actually check for reducing automatically. So there we go, 15 divided by 14 over 16, hit enter, and we can actually reduce that to 5 over 472. And I was actually going to assume that because 15 looks like it's definitely divisible by 3. And 1,416, I was thinking was divisible by 3 as well. So we can actually reduce this to 5 over 472 inches. Again, they're in the same units, and we also simplified. So ratios, same unit, and simplified. All right, let's look at our next question. We got a couple questions today. So here we go. So write down the problem, and let's do this. So get this one down. This is our second problem. The measure of two supplementary angles are in the ratio of 1 to 4. What are the measures of angles? Well, we can actually solve this. This is called using our ratio to help us find a quantity. Well, two supplementary angles, if you see the word supplementary, hopefully you automatically were thinking 180 degrees, going back to geometry. And we're going to set this equal, we want 1 plus 4. Okay? So that's what we want to have, a ratio of 1 to 4. How are we going to get that ratio? Well, I'll let you know in 1 second. I want you to try and think about it. So pause the video real quick. Okay, I realized when I said pause the video, I paused my own video, which, well, that didn't really help anything. Okay, so clearly 1 plus 4 obviously doesn't equal 180. We don't know what the two angles are, and so we can actually give them the variable x. Now, you're thinking to yourself, how can I give the same variable x? Well, we are the same angle, sorry, two different angles, x, and you can see here I actually have the answer popped up there. But the two angles obviously don't equal each other, but they're not equal to each other because one is 1x and one is 4x. So we add those two together, we get 5x. And again, this is the answer we should get. We're going to get there. And we're going to divide by 5. And when we divide by 5, we get 36. So one of our angles, this angle is 1x. So we're going to do 1 times 36. That's how we get this number right here. And then 144, that's going to be 4 times x, which is 36. And again, taking our calculator, doing 4 times 36. Okay, 4 times 36, we should get 144. Okay, and so that's how we do it. We want to use the same variable and add them together using the ratio. So we're going to see that type of problem quite a bit. All right, 2 more problems and we are done. And here we go. Alright, let's get started. The length of the sides of a triangle are in the extended ratio 3, 5, 6. The perimeter of the triangle is 98. What is the length along the side? So this is kind of like the last problem we just did. We have a perimeter and we're looking for the lengths of the side. So we get 98 and we're going to set it equal to 3, 5, and 6. But again, we're going to put x's on them, because that is going to keep the ratio consistent. Add them all up. That's going to be 3 plus 5 is 8, plus 6, I believe, is 14x, equals 98. Divide by 14. Okay, and double check our answer. I'm just going to use the calculator off here to the side. 7 equals x. Now this is not my answer because it asked me for the longest side. And according to this, the longest side is going to be this piece right here because it's 6x. So it's multiplying by the biggest factor. So we're going to do 6 times 7. 6 times 7, I don't know. I should know that one in my head. 42, just was double checking. So this is going to be the longest side. So longest side is 42. So again, we're using that same kind of thought process of here's our ratio 3, 5, 6. We're going to 3x, 5x, 6x equal to the perimeter of our triangle. All right. Last problem here. And this one's pretty easy. We're solving a proportion. So to solve a proportion, we are going to use cross products. So we're going to do 5 and x are going to get multiplied to each other, and 6 and 4 are going to multiply to each other. So let's go ahead and do that. 6 multiplied by 4 equals, and we're going to get x multiplied by 5. 6 times 4 is 24 equals 5x. Divide by 5. And here we're not going to get a perfectly even or whole number. And so when we're solving for it, we're okay with decimals in some situations. And so today we're going to go ahead and take this down to a decimal. I believe, if I'm not mistaken, this is 4 4/5. But I'm going to double check that real quick. 24 divided by 5, and we get 24 over 5, which is what I got. And if we do that, 4.8, which is 4 4/5. So we could also write 4.8 as well. So either or would work. Okay? All right, guys, be ready for our next class period, I suppose. And if you would, I would like to see everybody with a picture of... Okay, bye.